The only way that we can change the speed of any wave is to change the medium. If you messed around with the slinky or the simulation with the waves on a string, tension changed the string, so tension changed the speed of the wave. If you messed around and made like your own little pool with water in the bottom and played around with water waves, the biggest factor that affects the speed of a wave is the depth of the water. If you've ever been to the beach and seen how waves curl over and crash into the beach, the curling is an effect of the speed of the wave changing as the water gets more shallow. But we'll save that for a different course. If we're talking about sound waves, then the biggest effect on the speed of sound is temperature. Altitude has a minor effect, humidity has a minor effect, but compared to those, we can round those effects off to zero. Really, the only thing we're going to say that has an effect is the temperature. Sound does travel faster in warmer air than it does in colder air. I've messed around with this and tried to come up with an experiment so that you could figure out the speed of sound at different temperatures. There's way too much experimental uncertainty. When we tried it, we didn't get good numbers. So instead of doing an experiment, I'm just going to give it to you. The speed of sound follows this linear equation. If we know the temperature, that's going to be capital T. All we have to do is take the temperature and multiply by 0.59, and then add that number to 332, and that tells us the speed of sound at different temperatures. Basically, if we had a room at 0 degrees Celsius, the speed of sound is exactly 332, and every time we get warmer by 1 degree Celsius, the speed of sound gets faster by 0.59. I've only done one example, but it's kind of a simple equation. If I told you that, like generally speaking, room temperature is 20 degrees Celsius. If you've got your house sitting at 29 degrees Celsius, to figure out the speed of sound, we take that 0.5 number and multiply by 20. If it was 0.6, 0.6 times 20 is like 12, so we're going to get a number around 12. We take that number, 0.59 times 20, and then we add it to 332. If we had, let's do one together, let's say we had a negative 10 degrees Celsius. The speed of sound would be 332 plus 0.59 times, just plug in the t, negative 10. So it's 332 plus negative 5.9. Instead of writing it that way, I'm going to say 332 minus 5.9. Let's see if I can do math in my head today. If it was 332, if it was take away a full 6, the answer would be 336, but we didn't take away a full 6, or a little bit bigger. 326. Geez, I hope I can do math in my head today. I think the answer is 326.1. That's all I want to talk about in this video clip. Double check my math there, but if I give you from here on forward, if we know the temperature, when we get into these crazy air column questions, if we know the temperature, really what that means is we know the speed of sound. Speed of sound is just the temperature times 0.59, and then add that number to 332.